Well, happy Friday and welcome to today's edition of Fun Fridays from the Field Middle School Career Chats, brought to you by NICC's College and Career Connection Program, a member of the Iowa Intermediary Network. I am going to turn it over to Gina, our moderator, who will get us started today.
Thank you, Stephanie. Maddie, thank you so much for joining us today to talk about engineering and John Deere. So just get us started with a little bit about your background and how your career has progressed maybe so far.
Yeah, so hello everyone. My name is Maddie Booth. I am currently an engineer at John Deere, and I've been there for about 5.5 years now. I started in a hydraulics test role and transitioned to a different space that involves virtual testing. So you build a living, breathing version of the vehicle that you can test using simulation and coding programs like MATLAB and Simulink, Simscape, to be able to assess performance and test the machine virtually before we ever build one physically. And then recently I took a new role also in this space, but focusing on the controls and software integration side for those virtual models. So really exciting, a lot of time in the test area. I went to college at Montana State University. I have a degree in chemical engineering. So just kind of the early demonstration of the versatility of an engineering degree is I have a chemical engineering degree, but I do mechanical engineering and now kind of software and controls engineering for my job. So a very versatile degree avenue there, and a lot of opportunities at Deere to kind of jump around to different fields.
Excellent. Well, how we're gonna do this, just so everybody knows the structure for this afternoon, Maddie's put together a great little PowerPoint that kind of goes through some good information about engineering. So make sure to have your worksheet and fill out the pieces you hear that hits in her PowerPoint. We'll ask her a few questions more after her PowerPoint, and then we're going to go into an actual demo, which is super cool to see. So if you want to go ahead, Maddie, and launch into that PowerPoint so we can get all of that great information you put together for us.
Sounds good. Let me just minimize that. All right, so engineering as a whole is kind of what I'm going to cover in this presentation. And then beyond that, you know, what are some of the specifics at Deere that we do for engineering? And a lot of people have ideas, you know, of engineering kind of in their head, and they might think, you know, you're just at a desk and you just kind of sit there and grind away at stuff all day. But engineering involves a lot of different things, and we'll kind of start there. So high level, my dictionary definition of engineering is in the upper left-hand corner. But what that equates to really is solving problems. You know, with engineering, you are trying to find solutions for people to problems that they face every day, whether that's how do they harvest their crop, how do they build their house, how do they dig dirt to build a trench. Like, there's all sorts of avenues there for problems we need to solve every day. And this requires a lot of creative thinking and a lot of teamwork. So that cycle on the right, you'll see we identify a problem, we design a solution, we create a plan, then we create that solution, we test it, and then we start all over again. So it's a highly iterative process. And through the design phase and through this cycle, like from concept to the machine that goes out the door, or whatever you're building or creating, there's a lot of effort and a lot of problem solving involved in that. So my typical day as an engineer, as I've really driven home, is solving problems. And we work on new designs. We meet with team members. You'll see that note. We use a lot of computer programs, so different, whether that's 3D modeling, whether that's software programs like MATLAB or C code. And then we have to discuss what we're doing with our team members. So that's kind of where you get into the meeting with teams. We have to plan and carry out testing. So if we are doing work virtually or physically on a machine, that has to be coordinated and evaluated. We have suppliers that provide things to us, like, for example, tires or a valve or engines. And so we have to coordinate back and forth with those suppliers in order to make sure that we're getting, what we're requesting and they're meeting our condition requirements and things like that, delivery dates, all that sorts of stuff. And then kind of finally is this meet with customers aspect, right? As engineers, we need to know what problem we're trying to solve, and the customers identify those problems. So if we design a vehicle that doesn't meet customer needs, we're not actually solving their problem. So it's really important to get that customer perspective when we're making our engineering decisions and designs. So looking at education, you'll see a heavy math and science background, both in high school and college. Well, you don't have to take necessarily all of these. They're good to understand the different areas that you're interested in, right? Like I was interested in chemistry and math, and so I went into chemical engineering. And that's really what drove me towards that, honestly, was just as simple as those two things. So kind of identifying, things you enjoy, things you like in those fields is important. And then that hands-on aspect in high school, definitely don't overlook that. That experience is really, really meaningful. So it's one thing to know how something works in theory, right? But it's super helpful to then go out to the shop or go into your 3D modeling and try to build it for yourself and see what fails, see what works. You really kind of get this additional understanding from those hands-on classes. And even beyond classes, there's that extracurricular part of it, right? If you have an after school job or you work on a farm or a ranch or anything like that, you work on cars, like all of that kind of hands-on experience counts for sure towards developing that background in engineering. And then at the collegiate level, you see, additional math and science courses. And then you get into a lot of like engineering theory classes. So you take labs where you practically apply what you're learning. Mechanics, electronics, you might work in a shop, you might have to build something for a final project or thesis. So that hands-on aspect translates kind of with you throughout your engineering career as you go. One thing I will touch on here, that while math and science are really heavy in the background of engineering, it should not be a deterrent if you like to solve problems. So for an engineering degree, yes, you need math and science, but it's really like if that's not your strongest area, but you're better at solving a word problem than memorizing times tables or something like that, that problem solving capability really can take you a long way in engineering. And I would definitely encourage you to still pursue engineering, even if you aren't the strongest in math and science. So at John Deere specifically, there's multiple areas of engineering that, we typically hire. As I explained before, I'm a chemie doing software and controls, and I have a background in mechanical from my job at Deere. So it really isn't an inhibitor. The degree as engineering as a whole is super versatile. But for example, if you're in, software and computer science, you're developing software, you're creating controls. So you're telling the machine how to do what it's doing. Electrical, all of our systems in the vehicle are running on an electrical system. Just like, in your car, you have a battery and they're powering controllers and other machines and features. So that's really important. Mechanical and agricultural are kind of that basic design functionality of mechanical systems. So, how things work mechanically, physics, that kind of focus area. And then industrial and manufacturing are really, we have this product. How do we get it down the assembly line? What's the most efficient route for that? Make sure there's no defects. It's really focused on that assembly portion. So looking at areas of work that this falls into at Deere is, you have a design area, which is your creation of your vehicle, your test area, which is your evaluation and verification of the vehicle performance, functionality, pretty much making sure the machine does what we expect it to do. Operations is your manufacturing side. So logistics through the factory, how our machines are being built. If you need to help someone be able to build something better. Maybe you design them a custom fixture to be able to build the vehicle better. Marketing, which actually a lot of engineers flex over into because they bring that not that machine knowledge over into the marketing space. So you can imagine it's really helpful for selling equipment when you have designed it before. And then on the quality side, we have, rigorous quality standards that when we send a machine out the door, our customers need to know that it's been thoroughly tested and that it will last. And that's really what quality is focused on, is ensuring that our product is meeting the requirements to make it last. And then finally, just to reiterate one more time, engineering is a degree in problem solving and hard work. So first and foremost, you might get an engineering degree and apply it to an entirely different area like marketing. But to employers, it really shows through as this person can solve problems and they know that there's a lot of effort required to get there. And that's all that I had, Gina. I can quit sharing
Thank
for
you.
questions.
Thank you so much for sharing the different areas of engineering, because I think a lot of times I hear students say, yeah, I'm going to be an engineer. And then you ask them, well, what kind of engineering? And they say, oh, there's different kinds. So I think it's important, but it's also important to know, like, you started out in chemical and you've gone lots of different directions career-wise with that.
Yep.
So let's talk a little bit more about education and training needed. Maybe four-year degree, or are there other ways to be involved with engineering where maybe you could do less education or a different type of degree? Tell us about those options.
Yeah, absolutely. So engineering degrees are normally 4 years, and you'll want to make sure that you go to an ABET accredited engineering university if you are going to pursue a degree in engineering. And then there's supplementary degrees, though, like manufacturing technology, or if you're getting a business degree or marketing, that also have applications like at Deere specifically and in industry. So if you enjoy parts of engineering or parts of problem solving, but you don't want to be tied directly to engineering, there's multiple other different avenues that you could go. Even something like welding is super, super sought after in the John Deere space. Our machines are made of iron, so they need to be put together. And so like welding is definitely, if of an area of interest, that's another one where you could easily have a career at Deere from that.
Those are great examples. So in all of these careers, you need some basic skills to be able to function on the job, right? We would call those soft skills or employability skills. Do you want to tell us what you see as some of the most important employability skills when you're entering into your career?
Yeah, communication is one. Being able to convey what you're talking about to other people is really important because we work in teams. So being able to work in a team is an additional, really important skill to have. You have to keep an open mind. Our designs are never right the first time. We never ever get anything right the very first time. And so you're constantly working with other people and iterating through new ideas and trying to get others involved. And it really is this heavy teamwork collaboration. And then beyond that, you kind of need a little resilience and perseverance also. So you need to be able to, kind of push through when things are tough, because we often don't find those solutions right away. And it's really important to help us get to the solution at the end.
Excellent. Okay, so we're also curious on our worksheet here about what you really like about your career, and if there's anything you don't particularly care for that you have to do as part of your job.
Yeah, so my job is different every single day. Like one thing that I love about it is that variety. So I come in the morning to my other part of the house right now, and I work on a problem that's different than the problem that I worked on yesterday, or it's a different part of that problem. It's constantly changing. And to me, that's really valuable. It helps keep me motivated, and it definitely keeps me from getting bored. So it just really adds this incentive to want to do that job, which is really great. And then for dislikes, because I do work in a programming and a coding space, it can sometimes be challenging in that space. Things can break, you have to debug stuff. It's hard to find that solution. So it's pretty ambiguous in the middle, which makes it a fun challenge, but it can be frustrating at times.
Great. Well, we had some great questions that came in that our chat this morning. So I just want to ask you those because they were some
Sure.
really good questions. So we see that you're working from home. Does a lot of these engineering positions, can you work from home?
So many of them you can, and especially in kind of this post-COVID era, now that it's just really kind of become a new normal, folks work from home, they can work in the office. It's kind of a hybrid. Some folks work some days in the office, some out of the office. Like right now, I'm out of the office all the time, but my husband goes in 3 days a week um, and works from home 2 days a week. So there's definitely flexibility there. If your machine or if your job is tied to the machines, for example, like you're on the assembly floor or you are testing equipment in a test site, you have to be on site for that. So there are some times when it's not as flexible because it can't be. But most of the time, there is that flexibility in an engineering career.
Great. So you are able to work from home, but do you travel ever? Where's the fun, the most exotic places you've gone with your career?
Yeah. So in my first role as a hydraulics test engineer, I was able to travel to China. We have a facility where we build our excavators over there, and I was there for 2 weeks. On that, I got to visit a customer in Inner Mongolia, which is like way north China. And then the factory is kind of in the Beijing area. So that was a really cool experience. With that job, I also went to South Korea for a supplier visit. Which was also really interesting. And then on the state side, I've been to various parts of the country: Las Vegas, Austin, Texas, Los Angeles, California, different places, even just in the US for work for expos or Society of Women Engineers event with John Deere SWE. So it's been really, really great for travel, and there's a lot of opportunity within Deere to travel.
Can you touch on that, SWE?
Yes, yeah. The SWE stands for Society of Women Engineers, and this organization focuses on bridging the gap between underrepresented genders in engineering specifically, but in STEM careers as a whole. So, just statistically, there are more males working in engineering, for example, and so SWE's mission is to try to help encourage more like younger folks to be involved in engineering, and really just guide them to pursuing that career and then help them overcome challenges once they're in it.
Awesome. Awesome. So then before you have a little demo to share with us, but before we get to that, the question about salary, like we're not going to give
Yes.
away your salary, but what is like the entry level engineer position salary?
Yeah, so starting out, in engineering, and the internet will tell you a bunch of different things, but you're probably looking at like a 50 to 70 type starting salary. After over time, you definitely move up, and you'll easily kind of end up into like a six-figure number. It's also a very in-demand job, so job security is very sound with engineering. The world constantly creates problems for us to solve, and engineers will always be there to help solve them.
That is so true. So true. So I will let you share your screen now and
Yes.
do a demo. And again, if anyone has any questions, just place them in the chat.
Sounds good. Let me clip over to that. Yeah, so I'm just going to show here really quick, just an example. So for those who aren't familiar, this is MATLAB. It's a software program, and it's what we use at John Deere in my role to build these test models. I just created a really generic kind of entry point, so a way to tell our model what to do here. And we'll get back to this in a second. But what I wanted to show, and what I wanted to show is like if I run those first 3 lines, it'll open up something that looks like this. Oh, maybe. Awesome. So, and now it's thinking. So this is like an example of a model that I would work in every day, where you're building something in this Simulink and Simscape environment to represent an engine, to represent hydraulics. Maybe like in this case, I have a pump and I have a valve, two valves, and I have a reservoir for my hydraulic system. And you're building this version of this, and MATLAB solving equations in the background to tell you, for example, like for an engine speed in, what kind of flow do I get out of my pump type questions. And then this outputs data, and we can look at this data once it's spit back out and it's done processing. And then we can get plots, kind of like what's over here. So I can look at like a map of my system. I can look at energy consumption for my different areas in that system, for my engine, for my valves, for my pump. And I can break it down and look at just the hydraulic section. So this is really like when we talk about virtual test and virtual verification, it's really looking at, building physical systems in real life, taking like the engine out of your car and putting it into a simulation environment so we can evaluate it there.
Wow, is all I can say for that. That is solving problems virtually, for sure. Well, thank you for that. That's definitely a great visual.
Yeah, yep. I'm glad.
Do we have any questions for Maddie before we let her go for the afternoon?
I don't see any, but we probably, like I said, I answered some of the ones that were asked this morning.
Yep.
So we got through those.
Well, thank you so much for joining us today, Maddie. We appreciate it so much. You've really educated all of us about careers in engineering, and we appreciate that. So on behalf of NICC College and Career Connection and Iowa Intermediary Network, we really appreciate you joining us and our students as well. Have a great Friday.
Thanks, everyone.